closed-loop systems have captured both imaginations and headlines this year. These systems, like EGS, are considered scalable and hot dry rock systems with the potential, when perfected, to enable geothermal energy development anywhere in the world. Supporters argue that because they operate in a closed loop, meaning there is no fluid exchange with the rock, advanced working fluids can be used to make the systems operate more efficiently than water-based systems. These systems also do not typically utilize stimulation or fracturing techniques to create the reservoir, relying largely on advanced drilling techniques to engineer the subsurface, and thus supporters believe that seismicity risk will be greatly reduced in closed-loop concepts. So, what are the technological challenges associated with closed-loop systems, and what technologies and methodologies can be deployed from oil and gas to help drive down cost? What are the risks associated with these systems, and how can they be mitigated? Let's explore.
Well, hello everyone around the world. Welcome to our closed loop panel at Pivot 2021. I'm Silviu Livescu, your moderator, and I'm delighted to discuss with 5 fantastic panelists today. On Monday, we had an excellent panel on direct heat technoeconomics, and yesterday it was so great to watch an enhanced geothermal systems technoeconomics panel. Today, let's explore the technoeconomics of closed-loop systems and some hot topics that I have seen on LinkedIn and the Society of Petroleum Engineers Geothermal Community Board, such as why and where can closed-loop systems be used, how deep do they need to be, what is the economics, what are the technical challenges and risks, what are the benefits of using non-water working fluids, and so on. I'm going to ask each panelist to briefly introduce themselves and what their companies and teams represent in the closed loop systems area. And then I'm going to ask each of them a couple of questions. This discussion should take between 30 and 40 minutes. And after that, I'm encouraging all of you to send us your questions related to closed loop systems for our panelists to discuss how they fit in the geothermal energy space and where we are going from here. So now, without any further ado, let's start with the introductions in the order of the panel card from left to right. John, you are first.
Thank you, Silvio, and hello, everybody. My name is John Clegg, and I'm CTO of Hefe Energy Technology. So Hefe is a group of oil and gas industry veterans who've decided to take our directional drilling and measurements experience and pivot it from oil and gas to the development of high temperature directional drilling systems for the geothermal industry. We believe this will enable the drilling of directional wells at temperatures higher than 200 Celsius, which in turn will help to optimize the economics of closed loop geothermal systems. We believe that high temperature directional drilling and measurement is going to be necessary to allow closed loop systems to reach their full potential, and we intend to develop that enabling technology for the industry.
Thank you, John. Lev.
Hi, my name is Lev Ring, and I'm CEO of Sage. And like John, Sage is a team of oil and gas former executives. We have on our team 100+ years of experience of people developing, managing, and commercializing different oil and gas technologies. We started Sage a little bit more than a year ago with a vision that we can put together technology to engineer cost out of geothermal systems. And we believe that closed loop approach, which we'll discuss during this panel, is what will make geothermal global and cost competitive.
Excellent. Thank you, Lev. Joe.
Yes, thanks, Silvio. My name is Joe Shearer. I'm the CEO of Green Fire Energy, and our latest claim to fame is that we're a finalist in the Pivot New Ventures pitch competition tomorrow, with Sir Richard Branson judging, as Pivot is clearly more interesting and exciting than space, so he came back for that, right? Anyway, but more to the point, For the last 7 years, we've been developing closed loop technology for geothermal systems, and we're already commercial with projects in several countries. Our immediate commercial focus is retrofitting unproductive existing geothermal wells and expanding within existing geothermal resources to make them productive where conventional geothermal technology just won't work or the resource is degraded.
Excellent. Thank you, Joe. Eric.
Yeah, I'm Eric van Oort. I spent the majority of my career in the oil and gas industry, working for Shell for 20 years in a variety of companies. But right now I'm a professor at UT Austin, specializing in drilling and leading 2 large industry consortiums on drilling automation and well integrity. I'm also a principal investigator with the Geo organization, which actually organizes Pivot, and I act as an external advisor to EVER. At UT, I kind of specialize in drilling, as I already said, working with oil and gas companies and a growing number of geothermal stakeholders on technologies to make geothermal much more cost effective. So deep directional drilling, higher rates of penetration in hard rock, oil circulation control and mitigation, fluids and cementing, geomechanics, and last but not least, deriving value from data. So doing data analysis with machine learning and working on artificial intelligence.
Wow, excellent, Eric. I'm sure we'll touch all these topics today, at least briefly. And last but not least, Piotr.
Thank you very much. My name is Piotr Monkars, born and raised in Poland, the co-founder and CEO of Geothermal Solution, a company built to deliver geoheat in megawatts and tens of megawatts through a closed-loop geoheat harvesting system. I'm a professional engineer, Stanford University PhD, member of the National Academy of Engineering, and an adjunct professor at Stanford University for intro. In my 40 years at Exponent, I have learned what makes projects succeed and what makes them fail. I learned how to coordinate and lead global teams on global projects. My passion is to extend the enormous know-how of the oil and gas industry into geoheat closed-loop harvesting. What the industry has done making the United States energy independent can be used to make the energy world green. This is why Geothermal Solution was created. Thank you.
Wow, thank you, Piotr. So now let's jump a little bit into each one of your entities and see actually what closed loop means. And so if you want, this is a question for all of you, and again, I'll call you by names. Can you please a little bit about the work that your companies and teams have been doing on geothermal and especially on closed loop systems? So John, let's start with you again.
Okay, thanks. This answer might be a little bit different to some of the others because as a company, we're not developing closed loop systems themselves. We're actually developing the enabling technology that will make them work. We started to look at geothermal drilling a year or so ago, and initially we focused on what we were familiar with and what we'd seen in the past, which is hydrothermal wells. And hydrothermal wells for hot water and steam appear often to be drilled blind, and they're often simple vertical wells or close to vertical. So we didn't really see much of a requirement for directional drilling. But then we began to look deeper and we learned about EGS and in particular closed loop systems. And we became particularly excited about the opportunities that we thought they could bring, both to us as a company and also to the industry and to the world. We got very excited by the fact that there's the ability to drill wells anywhere on the planet and not just where there's hot water or steam close to the surface, and what that potentially does for things like energy independence, and also what it does for things like avoidance of grid congestion and placing the source of power close to the point of use. Most closed loop systems are going to be used to drill for electricity, and electricity really needs to be generated close to where it's used. So we like that. And we saw a lot of buzz and excitement around closed loop systems, but we realized that some of them are going to be quite technically challenging to drill. If you look at some of the designs out there, they require fairly complex and very accurate directional drilling. Now, the oil and gas industry is very good at drilling complex directional wells and very good at well placement, but the technologies that are used in oil and gas don't work reliably at the kinds of temperatures that we think will be needed to make geothermal development economically interesting in the longer term. And through a process of basically a two-pronged attack, we hit on a sweet spot of about 225 Celsius operation capability as an initial target. And we came at that for two reasons. First of all, it seems to be the temperature at which a number of other technologies are going to hit near-term limits. It was just yesterday, and I think it was on the EGS Technoeconomics session, it may have been on a different session, but we heard about how 230C is about the limit for long life from fiber optic sensors at the moment, for example. And we talked to a lot of people about things like tubulars, cement, drilling fluids, and so on. And 225C seems to be that kind of magic number. If you can get to that point, there's a lot of other adjacent technologies that are likely to work. But also in line with the great traditions of innovation, we don't want to break the laws of physics. We don't want to develop anything new. And I'd like to say that what we're going to do isn't rocket science, but actually, I think we're going to borrow quite a lot from the space industry, because the space industry has components, electronic components and sensors that we can repurpose and use. And a lot of those are already rated to 225C. So for a couple of reasons, 225 Celsius appeared to be that kind of magic number for us. And thanks in particular for space, we're going to be able to repurpose adjacent technologies, combine those with our knowledge of MWD and rotary steerable tools, and build a directional drilling system. So our first task is going to be to de-risk the electronics and the sensors. Those are the items that are going to suffer the most with temperature. That's where most of the technical risk is. We aim to have a prototype tool in 12 months and a working downhole tool that will take real measurements from a real geothermal well in about 24 months, and then add the capability to steer the drill bit, which is mechanical and relatively low risk, a year after that, so that within 36 months, we hope that we're going to have the world's first 225 Celsius directional drilling tool for geothermal energy development.
Wow, a lot of information there, John. And I'm sure the audience will have plenty of questions actually regarding several things that you said. Probably, you know, many people didn't hear them before, like the temperature limit, and you know, instead of targeting 350 directly, we need to to target a smaller temperature and try to make it work for that.
Target a small temperature and then move on from there. Eventually get to the higher temperatures, but use 225 as a staging post.
Right, right. Excellent, excellent. Thank you for that, John. So, Lev, what about you? What can you say?
Yes, and thank you, Silvo. So first, on the first part of your question, what is closed loop? Different companies and different people define it differently. So at Sage, as a closed loop, we understand as a system that has downhole heat exchanger, and we use supercritical CO2 as a working fluid. It's very similar to what actually Greenfire pioneered, okay, as a supercritical approach almost 10 years ago. We believe that you cannot develop cost-effective geothermal systems unless you do integrated design of subsurface and surface. I try to avoid the word drilling, not because I don't put importance on drilling technology, but when we're talking about cost, it's important to take account everything subsurface, not only drilling, but well construction, simulation, and what is everything that involved. And very often, drilling cost may not be the largest component of this total cost. So we developed numerical simulator that allows to integrate subsurface physical modeling with surface physical modeling. And it pretty much showed that without finding alternative solutions to ranking cycle heat conversion technology at the surface for mid-enthalpy heat, which is we consider between 100, maybe 20 C to 200 C, you cannot get cost solutions where they need to be global. And so when you switch to supercritical CO2, you can design the whole process in supercritical zone without crossing any saturation, without crossing saturation curves. And switching from Rankine cycle to Brayton cycle, it allows you almost to double efficiency. There are a lot of things that are critical for our designs. During last 2 days, there was a lot of people saying that geothermal will require very high flow rates. They're really high. We are talking about from maybe 10,000 barrels per day minimum to 50,000 barrels per day, which is significantly higher from everything that we have in oil and gas industry. And so that results in the need, whatever heat harvesting technology is being used, to develop large tubulars and ability to place these tubulars deep in the hole. We will start with implementing our design in geopressure regions in Texas and Louisiana, simply because we are trying to design a risk out of the pilot plans, and DOE has done a lot of work proving that there is a huge geothermal potential and brine aquifer that are available to flow at the rate that we need. We secure several customers in Louisiana and South Texas, and we hope to have pilot plan in place and operating in the next 2 years.
Excellent, excellent, Lev. Thank you very much. Joe.
Sure. Yeah, thanks, Lev, for the reference there. We did our closed loop demonstration project at Coso, California, which is a large geothermal location in Southern California, and it was funded by the California Energy Commission, Shell Game Changer Program, and J-Power, which is a large Japanese utility, through the Electric Power Research Institute. And we completed the testing there in early 2020. And we have a very thorough formal report that was published by the California Energy Commission, which is actually attached as one of my speaker handouts if someone wants to pick it up, or you can go to our website and download it there with the various other papers we've published relating to it. We also included as handouts some diagrams of various closed loop solutions that we're actually implementing. So one we call our simple retrofit solution, and that's using our downbore heat exchanger approach. Essentially what we did at the Coso demo, where we used both water and supercritical CO2 as the working fluids, and showed that we could take a well that couldn't be used due to high non-condensable gases and produce over 1 megawatt of power, even though our budget was only permitting us to insert 1,000 feet of the downbore heat exchanger into the well. There's another diagram there, which we call our multi-phase solution diagram. And it's also attached. And it shows our patent pending concept for steam and two-phase dominated resources that can't be produced conventionally, at least not without seriously depleting the water and pressure from the resource. So by attracting steam and condensing steam on the downbore heat exchanger, you capture the latent heat of vaporization in that condensation, which is a lot. And then driving that condensate down into the resource, back into the resource, so no water or pressure escapes from the resource. We take only heat, not mass, to the surface for power production. And while this can be used in retrofit wells, the big opportunity is to drill new wells that are tailored to the resource to vastly expand production from existing geothermal fields and green fields that don't have their permeability necessary for conventional technology, but aren't hot, dry rock either. But speaking of hot, dry rock, that's the holy grail. And it is shown in yet another diagram, and we've done a lot of modeling on that. And we're testing that actually in September on a project in Japan that will, I think, be the first real test of a true closed loop system in truly hot, dry rock. So we'll see if we can validate some of the modeling that Professor Van Oort has put in his papers. Thank you very much. And we expect to. So also, in order to show that closed loop geothermal can be fun and blow up anti-geothermal bias, which is out there, right? We have a diagram on our hot spring solution and just showing how closed loop can be used to avoid the main concern in hot spring areas, which is that conventional or enhanced geothermal systems could interfere with the natural flow of steam into the hot springs. So we did this analysis for a Japanese customer at the Obama Hot Spring Resort. And Japan has some of the best geothermal resources in the world, but geothermal actually has a bad name there because of this potential for resource interference. But obviously, a closed loop avoids this. So Japan's a great market for all the closed loop folks. Silvio, back to you.
Yes, excellent, Joe. Thank you very much, and thank you for providing the handouts. I hope our audience will read them. Eric, what about you?
Thank you, Silvio. Yeah, I'm very excited about closed loop, and I think it's the key to geothermal anywhere for power production, for reasons that we're undoubtedly will get into in this panel. The key to it has already been said before, is the reduction of drilling and well construction costs, right? Some significant improvements need to be made in order to get to levelized cost of energy that are really competitive with other kind of conventional and new green sources of energy. So that is primarily my focus to look at that, working towards that. And I think the key is really to transfer learnings from oil and gas to geothermal and to extend them further. As a technologist, I'm really excited about what is going on with laser drilling and drilling with the electrical discharges and millimeter waves and plasma and so on. I do believe that needs to be funded, and that may be the way we drill in the future. I just don't see it being used at scale and at a depth of 7 to 10 kilometers downhole, where we have temperatures above 200 degrees centigrade pretty much everywhere around the world. I just don't see those technologies working there. It's one thing to blast a hole in granite in a lab or on an outcrop. It's quite different to do that 7 kilometers down at temperature in an opaque drilling fluid environment, for instance. But there is good news in a sense that we can leverage oil and gas technologies. The rotary percussion drilling, for instance, drilling with mud hammers. We've been extending the envelope of PDCs, and we have these hybrid bits, chimeras between PDCs and rock bits. And then there's all kinds of technology that can be used to augment these conventional systems, like abrasive jetting and particle impact drilling. I look towards that indeed to allow us to drill much faster in harder rock. And therefore, of course, get the cost down and also be able to drill a lot more surface area at depth, right? That's the other key, to get more exposure to the heat reservoir. Now, I don't know if the audience knows this, but there is some good news to report in this regard. Over the last 2 years, we have kind of quadrupled the rate of penetration in hard rock. 2 years ago, the limit was about 3 meters an hour, 10 foot an hour. That right now is above 10 to 12 meters per hour, right? So 30 to 40 foot an hour, so a 3 to 4 fold increase. And in fact, if you do the modeling, right, you need to get to about 50 meters an hour, and then there's a significant reduction in the LCOE, right? Going much beyond that doesn't buy you very much, but 50 meters per hour, remember that number, is kind of the sweet spot. And you'll actually see papers coming out in that regard from my group and that of Professor Roman Shore in Calgary in the fall. But I think that's doable. I think that's possible, and very excited. And by the way, that's actually, that improvement in drilling can be used both for closed loop and EGS wells. So that's kind of universal applicability for all deep geothermal drilling.
Excellent, excellent, Eric. And yes, I like your comment about, geothermal applications in general that have the same challenges, and they are related to the lithology and the temperature, right? Not to the time of the system. And so in addition to drilling, then we have also to talk about completions and production engineering and all other stuff that we haven't even touched, just because we are, we have to drill our wells and then to lower the cost.
And we have to do them cost effectively.
Yes, yes. Thank you, Eric. And Piotr, what about you?
Well, first of all, I wish to thank the organizers for bringing our panel together to look at the new closed-loop geoheat harvesting approach. Contrary to some comments I heard, we firmly believe that today, accessing very high temperatures, and I mean 300 degrees C or thereabout, is feasible, making closed-loop delivered energy competitive with other sources. LCOEs of 4 or 5 cents per kilowatt hour. The materials and processes are already commercialized and to a major degree implemented by the advanced oil and gas exploration production companies. They need careful integration for application into successful geoheat exploitation at scale. The most important thing that we have to face here, our panel has to face with the world, is to move beyond the simple bromide that convection works and conductivity don't work together. That convection works is fine, conductivity doesn't. This sounds like a new law of physics which should not be constraining innovation. Accessing a greater volume of the formation through our thermal rich enhancement that we develop a geothermal solution with our hundreds of years of experience on my 40 people panel or team, allows us to move past the inherent limitation of the rock's conductivity to increase the heat flow towards the borehole without the resource depletion. After all, no matter what we do, is what the rock gives to us controls the process today. Now the issue of drilling at those temperatures with directional tools. I am looking forward to those great tools that are being discussed here today that will be developed, but we have plenty of locations around the world where at relatively shallow depths, we reach temperatures of 250, 300 and beyond. And so we don't need to go precisely directional. We just need to reach those areas and stay in them long enough. So the directional tools at the beginning of the process are important, up to the 200, 250. Afterwards, call it blind drilling. That should work. On this panel, we understand the societal need to make a difference through tens and hundreds of megawatts from a utility scale green energy plant. If we bring a kilowatt, megawatt, that doesn't make much difference to the world. So we need a dozen and hundreds of such plants around the world. As such, the geothermal solution heat harvesting technologies, which is a closed loop, we don't take anything out of the ground. We circulate closed loop in technologies that were proven in the last 50 years by the basic PWR systems. We have then energy delivered 24/7 at the levels that I discussed. The key differentiator of our geoheat technology are the maximized heat recovery from very hot formation by employing the well-understood closed-loop principles without injection or displacement of fluids in the formation, thereby avoiding all possible implications and without using vulnerable machinery or electronic that cannot survive those conditions that are today not available yet. I'm looking forward to them, but they are not available yet. And the world cannot wait for us to develop them. Thank you.
Excellent. So thank you very much all. Really great descriptions of what you are doing and where you want to head from here, what kind of technologies you are using. And actually, I like, that we are talking about the description of the closed loop systems, because it looks like, not two companies have the same kind of technology or the same kind of focus, right? And so we already reached 30 minutes, and we have plenty of questions from the audience. Actually, way too many to answer all of them. But I would like to start taking some of them. And so the first one, and I ask again, I'm going to call you by names, but please try to answer, within 1-2 minutes at most, just to have, time for more questions. So the first question I think that is relevant after our first question is, what is the low-hanging fruit for closed-loop systems? Piotr, let's start with you this time.
The low-hanging fruit are the locations that are around hot zones on the global map. The Pacific Rim, part of the Mediterranean, part of the Red Sea area, some spots in Africa, a lot of hot spots within United States. That's the hot low-hanging fruit, where you go to the depths of between 3 to 5 kilometers, where you don't have to worry about the exact direction. You just worry about the length in the heat rock. And that's the low-hanging fruit. This is what we should concentrate. This is what will allow us to show to the world that this is for real. And I am sure the money that was lacking so badly for development of tools for drilling in those conditions suddenly will appear on the scene. Thank you.
Excellent. Thank you. Eric?
Oh, no, I agree with Piotr. Indeed, in existing geothermal areas where you don't have natural fractures, or where hydraulic fracturing is really difficult, so EGS is not possible or not economical, right? And I think that's where Piotr and also probably is a better question to be answered by Joe, right? So that's where GreenFire and Piotr kind of focus. From my perspective, because I'm interested in drilling deeper in non-geothermal areas. I mean, that low-hanging fruit, those areas are good training areas for us to mature some of the drilling technology, right? On wells that are simpler, lower cost, right? To get really our training hours in, and to learn, and then to take it deeper and to take it everywhere.
Excellent.
I should probably respond to that one too, on low-hanging fruit, because at GreenFire, we see the low-hanging fruit is really working with existing geothermal resources initially, and then advancing across this temperature, permeability, water, resource, and pressure spectrum. In fact, we have one of the additional handouts is that spectrum slide. And where there's a chart that actually shows where we think geothermal is going on a timeline, and also with closed loop getting us there. So geothermal, conventional geothermal is great in the high temp, high permeability resources, but there are lots of problems that can arise, and permeability or water availability is often the challenge, which conventional production technologies typically degrade the resource further. So closed loop can be a solution there. But there's this vast middle range of permeability, water resource, and pressure that's not totally convective, or as convective as you'd want in a conventional resource, but still excellent for a closed loop alternative. And that's one of the areas we've been focused on. So where it's an expansion of an existing geothermal resource, all the infrastructure is in place, the resource is fully understood, permits are in place, drilling challenges are already identified. So a project can proceed very quickly in a matter of months, not years, and without the risk that a project can die after years of work on it. So we see that as definitely low-hanging fruit. Where it's a greenfield opportunity, then the closed loop allows us to de-risk the project by designing wells to all be successful by having a closed loop alternative for each well, either upfront or when and if it degrades or has problems for whatever reason. But we also can pair with closed loop with new technologies, whether they're EGS or downward fracking, such as Sage is pursuing, what we call finning, such as Geothermal Solutions is pursuing. And Greenfire in the future of geothermal is all about bringing heat to the pipe while not depleting the resource. So we're happy to combine with other technologies that are going to de-risk and improve profitability. And then as you go along the spectrum of water, pressure, and permeability, then you get to the hot, dry rock, which I agree is the holy grail, and we all want to be there. And I think these are initially going to be in high electricity price areas and where there are subsidies, they're direct or indirect through feed-in tariffs. But over time, with all the advances we're hearing about, including many on this panel, our goal is to focus mostly on hot, dry rock projects rather than ones where convection is still valuable.
Excellent. Thank you, Joe. And Lev.
Yes. So from a Sage perspective, the low-hanging fruit is geopressure mid-enthalpy sedimentary resources in Gulf area, in Texas and Louisiana, perfecting downhole heat exchanger, supercritical CO2 turbine, and addressing cooling technology, and then moving globally to, by the way, geopressure resources are globally available, and it's estimated at above 100 gigawatt globally. We have footprint available in Texas. We have very well understood resources, and that's what we're going to start and engineer risk and cost of our system. And with 20,000 wells being drilled every year in Texas, there is huge potential to upscale. We believe that we can get from each well 2.5 to maybe 4 megawatt, which gives tremendous growth potential.
Very good, very good. And John?
I'd start off by it's not exciting when you agree with other people, but we heard about hydrothermal. At Hefe, we've been working with a hydrothermal operator in California, and based on conversations with them and looking at some of the operations, and also based on reading the report that Joseph referred to earlier, we see that there is definitely potential for significant improvement in some hydrothermal areas by using closed loop systems, and that could be for the industry, very, very new, very early stage, low hanging fruit. From a Hefe perspective, I mean, going back to the technology development, definitely we see the 200 to 225 Celsius area as low hanging for us, because we believe the technology exists for us to be able to do it. But picking up on a point that Piotr made, I think that the potential is there to go a lot higher, and we certainly wouldn't rest on our laurels when we get to that point. Like I said earlier, we think that's a staging point. We think it will be necessary to develop drilling technology, and I think ultimately it's going to be useful to have directional drilling technology that works in higher and higher temperatures. It is a bit more challenging than getting to that 225 Celsius number. One of the outfits we're talking to is JPL in Pasadena. Those guys are currently working on electronics that have to work at 480 C for the Venus lander. And if we could partner and work with people like that, then the potentially no limits to what we can achieve in the coming years. But we're going to take it a step at a time, and our low-hanging fruit is 225 Celsius first.
Excellent, excellent. Very good comments. The questions keep coming. I would say probably half of them actually are about comparing closed loop systems with EGS. And so to me, actually, it's not about comparing them, just because in my opinion, in my humble opinion, we need to work together, and probably we need to find ways where closed loop systems work and other places where EGS system enhanced geothermal systems work, right? If you think about it, even the direct heat system that we're discussing on Monday during the panel on direct heat, those are closed loop systems as well, just lower temperature, but they are closed loop systems. And so we need to better define the value proposition here. Just because we want to scale up the geothermal energy production doesn't mean necessarily that we are going to have only one solution to all our locations and applications and so on and so forth. So the next question that I would like to take is, what about repurposing existing wells, either oil and gas or even geothermal wells? Can closed loop systems actually bring any value for repurposing wells, existing wells? And
well, maybe that's a question for me.
Sure.
Because we're retrofitting wells now. I got a letter of intent this morning from a customer on a well, and the most interesting thing from a commercial point of view is not just repurposing one well, but that resource is a 25 to 50 megawatt resource. And we got a green light on a couple of wells last night in another resource, right? So these are retrofits, and it won't surprise you when you sit down and talk to existing geothermal owners about the opportunities, and you talk about these huge billion-dollar projects, which are fascinating. One of the first responses is, well, that's great, Joe, but what can you do with my bad wells now? So we listen to the customer, and yes, indeed, we can retrofit a number of so-called bad wells, but they aren't really bad wells. In fact, we spend a lot of designing of a closed loop system to make them productive wells. And so if you're turning a liability well into an asset well, that's a pretty easy place to start. And then our theory, and we're already seeing this, is you expand from that initial relationship retrofitting individual wells into showing that the closed loop technology is appropriate for the broader resource. So the purpose drilled wells, usually, at least in the project we're looking at that start with retrofits, are in this middle permeability area where you still have the advantages of convection, but conventional technology isn't going to work. Partly, a number of resource owners don't want to produce conventionally because that produces water out of the resource, that limits pressure, and that reduces pressure. And you really don't want to rob from Peter to pay Paul. You've got an existing resource there. So let's use closed loop to preserve the resource, increase longevity of the resource. So just retrofitting individual wells can work and is economic, and we're not engaged to do that unless it's economic for the customer and economic for us. But the bigger opportunity is expanding that into the broader resource where you know enough about the resource and some of the troubles with the bad wells that you can't necessarily count on it working for a conventional technology, but you can plan for it to work with closed loop system. So so that's definitely an opportunity. Now, if you're talking about retrofits of oil and gas wells, and there was a great panel yesterday on retrofitting oil and gas wells, we're very interested in that as well. And we have a patented green drive solution that uses closed loop geothermal to actually pump oil wells, because then you can save the electricity that's needed for pumping, and thereby making oil and gas more green. And oil and gas wants to be more green these days. But it's economic because you're producing the power that would otherwise be needed to pump the oil well. And then there are some oil wells that are just good candidates for what we call a simple retrofit. So retrofits are great in their own right, but they lead to really wonderful opportunities for all of us.
If you don't mind, let me give you a little bit different perspective on the same question. So from Sage standpoint, I absolutely agree with Joe on hydrothermal wells, and the specific for hydrothermal wells usually that they have very big bore to the depths. when we are talking about oil and gas existing depleted wells, one of the limiting factor is that you would have 4.5 or 5.5 tubing cemented at depth. And it's very difficult to provide flow rates that are required to generate commercial values of electricity in mid-enthalpy region. With that said, there are exceptions. We actually own well that in South Texas that goes down to 19,000 feet and 225 C, and it has 8.5 hole to the bottom. It was drilled as an exploratory well. In many technologies, including closed loop technologies, there needs to be re-inject fluids back into the formation. Existing wells can be used for injection, for sure. And then there is a tremendous opportunities offshore, because when you go offshore, you are dealing with well bores that is needed to manage flow rates, but also you don't need to worry about cooling. In system that we're looking at, with cost of turbines is really low. 3/4 of the surface cost goes to cooling. Offshore, you don't need to worry about.
Excellent, excellent, Lev. Anybody else?
Yeah, if I may say something about that. So I agree with Lev. I don't want to be the Debbie Downer on this panel with respect to repurposing wells. I think Joe talked about repurposing existing geothermal wells, right? And a lot of people are now getting very excited about repurposing old oil and gas wells. And as Lev already said, there are some issues there, particularly the fact that if you want to produce electricity, then you have to have the right temperatures and the right flow rates, of course. And a lot of these wells, from just the way they're constructed, don't lend themselves to that, certainly not on the production hole sizes. I see a lot of people getting really excited about this because oil and gas is facing this big problem right now with well abandonment, right? We have literally millions of wells to abandon around the globe. The asset retirement obligation of companies is huge, and wouldn't be great if we could turn all those wells into geothermal wells, right? Wouldn't be great for states to turn all those orphaned wells into geothermal assets, right? And I think to a certain extent that will be possible, particularly for direct use of heat, but it will also be very limited. And in some cases actually be dangerous, right? A lot of these orphaned wells, especially old wells, have significant well integrity issues, are leaking. That all needs to be fixed and so on. So I think you need to look at this strictly as a horses for courses opportunity. That will definitely be there in select cases, but I want to temper the expectation and the excitement a little bit, because I don't think that there is kind of general applicability where we're going to be turning all our old oil and gas wells into geothermal wells.
Yeah, and just to confirm, Eric, all of our current commercial projects are geothermal wells. So you're right.
I would like to add.
It will just be better just to drill new wells, right?
Yeah,
and
well,
the production hole size
that's ideal, but it costs a lot of money. So okay.
Right. We'll come to back later. So Piotr, please.
I would like to add a couple words and a word of caution here. First of all, let's not forget that we are about bringing heat energy to the surface. That's number one for closed loop. And the heat has to be brought in quantity that makes commercial sense. This is not an academic exercise or solar panel on the roof of my house. And then if we start going into projects that somebody needs that project in order not to have to decommission the well, save some money, or one of those gimmicks, we are going to shoot ourselves in the foot. So let's be cautious about jumping into something that right now we can put in corporate papers that we are doing it, and we are going to shoot down the EGS, the closed loop system. While the oil wells in areas which have high saturation with water or highly fractured could be good for EGS. They provide no value to us, quite frankly. Quite frankly, I have looked at it, I had offers, and no matter how I try to cut and slice it, at the end of the day, it became more risky and more expensive. So be cautious about being duped into serving somebody's purposes related to their obligations. There is so much knowledge in the oil and gas industry in those fields where those wells are. That's the value that they bring, not the old rusty well that is leaking. Thank you very much.
Yeah,
Thank you.
I
John?
just add to that. Yeah, I agree with Eric and Peter about the potential risks with well integrity, and you don't always know what you're going to get when you open up an abandoned well. And the other point about oil and gas wells, I think, is we said earlier that oil and gas technology hasn't really been developed for drilling at temperatures above about 175 Celsius, occasionally 200 Celsius. And I think one of the reasons for that is that there aren't very many wells that have those high temperatures. And so going back to what we said earlier about temperature being better, the yield from these relatively low temperature wells, looking forward into the future as we develop technology, might be disappointing. Hydrothermal wells could be different, but I guess the point I'll make there is that it could be very good to repurpose existing hydrothermal wells as part of a technology roadmap in order to develop and understand how these systems are going to work. But if we're going to be ambitious, and if we're going to see this industry significantly scale, and the kind of numbers that Lance was talking about earlier today, I doubt that there's anything like enough hydrothermal wells to repurpose. So we're going to have to drill a lot of new wells anyway. So we may as well figure out how to.
Right.
Can I add one more word?
Well, one of the things we say to respond to John there is with the retrofits, we land a customer, right? But it's the real business model is to land and expand into the broader geothermal resource. That's the goal, and that's where you get scale that is much greater. So I agree with what you're saying.
That makes sense. Yeah.
I commend the landing of the customer, but we are here to develop solutions for the world. So I wanted to add one more thing on what John said about the geothermal wells. Geothermal wells that are not performing are usually next to a plant that is not performing because it doesn't get the heat. If we sink our closed loop next to it, we bring the heat to that geothermal plant. Suddenly that asset, which is about 50% of the cost of the geothermal, suddenly that asset comes back to life. There is not far from where I am sitting, a big field of geothermal that is operating at half of the installed capacity because the wells start producing. Imagine if we added now close to gigawatt of heat for them, how much value we would bring to the society. That's the opportunity, not using the pipe that is sitting in the ground. Thank you.
All right. Excellent comments. I really like the passion. So the next question we are taking from the audience is related to lowering the cost. So, the perception is currently the geothermal wells, including the closed loop systems, are expensive. And so where do you see the opportunities to lower the cost, innovation, and everything actually that can lower the cost of a closed loop system? Let's start with John, just like on the panel card.
Yeah, sure. I mean, drilling and well construction is a significant part of the cost of the overall geothermal installation. Estimates vary, but most people seem to agree that it's quite a large chunk of it. And the more optimistic forecasts of levelized cost, maybe in 10 years time or 9 years time from now, sort of 2030, 2031, in the region of maybe 3.5 to 4 cents. Many of those are assuming some advances in well construction. And a lot of the assumptions they make are around things like improved penetration rate. Eric talked about that earlier, and I think we've seen fantastic progress with things like PDC bits in the last few years in terms of being able to drill these hardened crystalline formations, things that we wouldn't have believed were possible a few years ago, especially if, like me, you'd worked with PDC bits for much of your life. Never believed that this would have been possible. But I like to think about analogies as well. And one of the things that strikes me is the potential similarity between what we're trying to do here and what happened in the US over the last couple of decades with unconventional oil and gas wells, where an industry that appeared to be uneconomic was made economic and managed to go through and survive, not entirely unscathed, but survive a number of crises, 2014 and then more recently as well. And that was really catalyzed by two things. One of them was stimulation or fracturing, and the other one was horizontal drilling. Horizontal drilling was a major enabler of the development of unconventional oil and gas wells. And I think it's going to have a similar impact, a very dramatic impact that we're not really forecasting yet on the development of both EGS and closed loop wells. And really that's why my team and I have dedicated a big chunk of the last year or so of our lives to thinking about this.
Oliver, if I may, I actually see opportunities is integrated system design. Geothermal today to us look not very different from what we was focusing in 90s with deep water development. Actually challenges technical are probably easier to overcome. But again, without addressing together surface and subsurface, going to supercritical CO2 turbine, when we are cutting cost of turbine is going to be 5 times cheaper than cost of steam turbine or binary Rankine cycle. Now all cost sits in cooling system. Well, we're going to address this. I'm very excited about what John is doing. John and I worked for years, shoulder to shoulder. And why I'm excited, not because of 220, but because I know that John is going to make this system that works at 220 reliable at 170, 180 that we don't have today and we badly need. Okay, reliability of what we're doing. Fred Dupree today said that at Ford they reached 65 feet per hour drilling through igneous rock. That is absolutely unbelievable and fantastic. That's what opens opportunity, engineering cost out of geothermal systems.
Excellent, excellent. Joe?
Yeah, in terms of technical drilling and completion improvements, we really appreciate all the advances that our oil and gas partners can bring to the table. And there are a number of panels, including folks on this panel that are, John in particular, that are talking about those advances. So in a word, I'll keep it short, reducing cost is the main thing that we would expect. And of course, there are many elements to that, but drilling and completion advances are key.
To me, the bottom line of the story is how do we make the rock transfer the heat faster to us? That's the bottom line of the story. This is what the oil and gas industry, particularly unconventional oil and gas, have developed. If we use those advances to stimulate the rock to bring the heat faster to us without interfering with the resource, without causing micro tremors, without pumping precious water into the ground. I mean, let's be sane here. The world is now pricing water at the price of oil in many areas of this world. And we are talking about pumping millions of gallons of water into the ground. Whether we recover it or not, I don't even want to touch that topic here, okay? So we have to focus on how we can bring what I call dry heat to the surface. For me, the model has been invented. The model is called PWR. We just don't want that nuclear reactor. The Earth is the reactor. If I can bring the heat through closed loop, tube in tube, I am using tube in tube, as you all know. If I can bring the heat to the surface, then I am going to go for a loose solution, how I convert that heat into more effective pushing my turbine on the surface. I don't need to put my turbines 3,000 meters on the ground. I am going to use the technology that John is developing to go deeper, to higher heat. I want to get to 350 degrees C. Yes, today I can only go blindly there and stay there blindly. I would like to go there and stay in an educated way. That requires new tools. But the bottom line of the story is talk to the rock. Convince the rock to give you more heat faster, and then grab it and bring it to the surface without interfering with the resource. Thank you very much.
Very good, very good. And Eric, we have 3 more minutes before the closing remarks, so
Okay.
please, your floor is yours.
I'll be brief. I don't talk to rock. I crush it. Drillers are simple beings. But when it comes to drilling and well construction, I do think that that's the major problem area for us to address, right? And I'm like a kid in the candy store. I see opportunities everywhere, right? Particularly in terms of transferable learnings and skills and technologies from oil and gas. I mean, we make really good bits, right? That can drill really hard stuff. And we know what damages bits. It's not necessarily the hard rock. It's drilling dysfunction. So if you can apply the learnings that we've had with the shale revolution on drilling optimization and keep bits intact, and you can drill longer and faster. And that's exactly what is happening right now, right? There's a beautiful example of transferable learnings from the shale revolution. Deep directional drilling, right? John is working on that. There are several service companies working on that. There's new developments in metal-to-metal motors there that make it possible to drill at 300 degrees centigrade, right? Have already been used in Iceland at IDDP. Apart from that, I mean, there are other areas for us to focus on, right? Loss circulation is a problem on every geothermal well, especially when you drill closed loop. You can be really aggressive dealing with loss circulation because you're not producing through fractures. So a big area for us to address, right? Managed pressure drilling has not been used in geothermal. I see great opportunities for that, right? Probably my biggest excitement is for machine learning and artificial intelligence, right? Machine learning in terms of data set analysis and getting the highlights out of the data that allow us to push the envelope on the performance even further. And then artificial intelligence for control systems, for instance. I think that, for instance, deep geothermal wells need to be drilled with smart auto drillers that are guided by AI, and that's something that my group is working on. So as I said, I'm like a kid in a candy store. There is so much to do. In my closing arguments, my closing remarks, not arguments. It's not a trial, but I'll give you some thoughts about some of the hurdles that I might see, right? That might actually slow us down. There are some things that we need to address and take very seriously. Otherwise, this revolution in geothermal is not going to go as fast as we want it to.
Excellent, fascinating discussion and excellent points. We still have plenty of questions from the audience. Unfortunately, we are running out of time. So I would like to give each of you, a minute for your closing remarks. And by no means this is going to be an ending discussion. I'm really looking forward to continuing this discussion and hearing about everything you are doing. And so now let's start with in the reverse order of the panel card. Piotr, your closing remarks, please.
Well, thank you very much again for putting that panel together. The dream of closed loop, hot, dry rock, heat harvesting comes through today because of many technological advances came to fruition as recently as within the last decade. The success of closed loop is possible because of great change in available technologies. Today, we can drill deeper, cheaper, directionally in high temperature rock. We have the understanding of rock penetration mastered by the unconventional oil and gas companies, and insulating materials, the heat conversion to other forms of energy, and very importantly, the ability to install the harvester into significant depths where temperatures are well above the low efficiency 100 to 200 degrees C range. Closed loop technology is real and ready to deliver. Our studies indicate that geoheat can give us electricity at LCOE in the range capable of competing with fossil fuel baseload incumbents. This solution can be deployed globally to deliver true renewable green energy with economic scale to benefit mankind. Thank you.
Thank you, Piotr. Eric.
Yeah, so the future, I think, for closed loop and closed loop for geothermal anywhere is bright. I see it as so despite what the critics say, the business case for closed loop geothermal is sound. You see companies making investments into closed loop companies. You've seen Chevron and BP funding ever, and they wouldn't do that if that business case didn't work. There is a technology staircase, of course, to get the LCOE down, and that staircase looks completely doable, right? From my perspective, it focuses around, of course, drilling and well construction cost reduction, but we've seen great strides toward that over the last couple of years, and there is no reason to suspect that suddenly we wouldn't progress any further. In fact, I see plenty of opportunity for that. I do see some risks ahead right now with respect to kind of the pace of technology development and the funding of it. The funding, for instance, from oil and gas companies has been significant, but it dwarfs their investment into other technologies, right? Oil and gas companies spend a lot more money right now on wind and solar than they do on geothermal. And we're largely relying on small companies like John's. No offense, John, but I'm assuming your company is still small. And then also kind of oil and gas service providers and traditional geothermal service providers to develop all this breakthrough technology in the future, right? With a relatively small market still, right? And it's a difficult thing to do for these OEMs and service providers. Basically, we're telling them, believe in the field of dreams message of if you build it, they will come, right? And I can see that potentially as a real hurdle, this underfunding in technology development. I hope to see a significant increase in that. Otherwise, we'll see a stagnation on the technology progress and the adoption worldwide of geothermal, and certainly decelerating the road towards geothermal anyway. So I'll leave it at that.
Excellent comments, Eric. Thank you very much. Joe.
Thanks. Yeah, thanks to you and Jamie and Pivot for putting this conference together, which provides a great vehicle to allow the oil and gas world to really apply its phenomenal expertise and impressive history of innovation to make geothermal the major energy supplier that it really should be. We've seen the oil and gas industry get interested in geothermal before, but with the energy transition, it's Pivot, it's causing this to be a serious transition, a real pivot. And our approach at Greenfire for working with existing geothermal owners on real commercial projects now, with the active support of our oil and gas partners, can help bridge that historical gap that's existed between these industries for the benefit of everyone. So it will move the industry forward much more quickly. So thanks to Pivot and the fellow panelists, and full steam ahead.
Excellent, excellent. Thank you, Joe. Lev.
Well, I'm super excited because all the energy, all the discussion that's going on at Pivot and outside Pivot, there is definitely tremendous growth of interest to geothermal systems. We are very excited about our partnering with neighbors. They bring tremendous footprint, drilling expertise, automation, robotics, data analytics. We feel that all the pieces coming together, now it's our challenge to implement them, design costs out, and that's what we're good in oil field. We're good at designing costs out.
Thank you very much, Lev. John.
Okay, very quickly. Yeah, I mean, we all know that geothermal has this great combination of low GHG emissions and high capacity to be able to provide baseload power. But also closed loop offers us something in addition to that, which is really the ability to provide that power anywhere in the world, in a city, in an industrial complex, even on the site of an existing coal-fired power station to leverage the high tension lines and so on. We believe at HEFE that the economics can and will be competitive with other sources of power, as we've heard from a lot of the other panelists today. And it looks as though technology is going to be a key enabler. Lev brought up the integrated system design as a requirement a few minutes ago, and I think he's absolutely right there. It's not just about a drilling tool, it's not just about a rig. One of the things that I'm excited about is that we can provide technology that won't only allow directional drilling. Once we've got downhole capable high temperature memory and processors and so on, there's going to be a whole bunch of other stuff we can do with that as well, and allow us to build really truly integrated systems. And with that, Sylvia, thank you for this opportunity. Thanks, Jamie, as well, and I'll let you finish.
Excellent, excellent. Thank you very much again. Wow, what a great discussion and how much food for thought. I would like to thank our fantastic panelists one more time, and I'm urging all our attendees to reflect on how we all can collaborate and do our part to help scale up geothermal energy faster, like Eric said. I hope that you all agree that the time to act is now. Thank you very much for your attention. See you next time. Bye.